Hey guys, it's Tuesday, 9/27 on August 7th, 2018, and I've been looking through these videos from Mental Boost, and he put up this video called Car Fire Damage Walking Tour, Trees Shredded, Strange Damage Patterns. The links will be in the description, but there are some telltale signs here that there have been electromagnetic frequency problems just based on the shape of the plants and trees. And I want to take a second here and point these out and explain to you what it is exactly that I'm looking at so you guys can understand this. See this cedar shrub here? How it's divided into three different directions? That's not normal. Okay? Cedar shrubs usually grow straight up and together, but something parted this. Now, there is a process in a plant, and you guys probably know what it is, but I'm just going to go over it real quick with you guys. It's called phototropism. And phototropism is the response that a plant will have. They say it's the growth response, but it doesn't just happen when it's growing. This is a physiological response that a plant has to electromagnetic frequencies, specifically to light. However, the hormones that govern this process, called auxins, okay, they're photoelectric sensitive, so they'll actually go to the darker side of the plant to get the plant to go into this physiological response that'll alter its water pressure, and its cells adjust and its polarity adjusts so that the plant ends up leaning towards the light. But even in absence of light, you can stimulate those auxins to go haywire if you have electromagnetic frequencies pulsing through the atmosphere. So when you see a plant that has very bizarre morphology, or the shape is very strange like this, it's not growing totally normal, you can start wondering about whether or not there has been some sort of electromagnetic frequencies, especially when you have, it's not just one branch. But let me show you. Take a look at this shrub. This shrub is a telltale sign. Unless you want to tell me that some invisible donut fell on top of this tree, there is something very strange happening with the shape of this tree and the electromagnetic properties of what happens in a tree to keep it, to retain its shape. Now, the beautiful thing about cedar is that because the branches are so malleable, they do a beautiful expression of they start weeping when it's like they're weeping in response to electromagnetic field changes. Okay, that's not what happens with stiff trees like oak trees and maple trees and other trees. They don't have the luxury of having this flexibility inherent in their branches. So when you see this happening around a cedar tree, the other thing you need to look for is, has there been other electromagnetic physical stress demonstrated in other trees, in other branches? Now, what you'll see in other plants is that when they get subjected to really high intensity electromagnetic stress, they will break. The branches will actually break. Why? Because they don't have the flexibility that's inherent in these really supple branches that you have on a cedar tree. Well, what's so fascinating about this video, you guys, is that these guys go on a walking tour of this neighborhood, and they are shocked by what they consider to be a tornado. But what I want you guys to notice is all they're actually observing here, you guys, are uprooted trees and broken branches. They're not actually observing the debris field of a tornado. And here's a very good of many examples in this video, that you have a garbage can right underneath a huge oak tree that broke in half. This is not the only oak tree that breaks in this video. As this guy goes through, he shows all these broken oak trees, huge, heavy, sturdy, thick trees, and tons of garbage cans, you guys, that at worst were tipped over when the tree fell. You see? Now in my neighborhood, you guys, we use the same kind of garbage cans, and I can tell you we've had some pretty heavy winds and storms that have come through, and they've taken our garbage cans clear down the street with all the garbage strewn around in them, and they never once broke any of the very same trees that we have in our neighborhood. So there's something else going on here, because for you to have these garbage cans, I don't care, I mean, even if these things were filled with bricks, all right, a tree is still far more sturdy than a garbage can. And the fact that all you have here are a couple of garbage cans tipped over, no, there's just something else going on here. So I want to just point out a couple more examples of this where you see these huge broken trees, and see how it's kind of charred around the edges of these trees. Guys, this is a telltale sign of electromagnetic damage, injury to a tree. See how it's charred here? These branches are charred not because of a fire. These are charred because there's been electromagnetic flux in the atmosphere. And what has made a cedar tree, which is super soft and supple, open up like an onion or a banana, has actually fried the innards of an oak tree to the point where it's so stressed that it actually broke. I mean, look around here, you guys. This does not look like a tornado has gone through here. It looks like charred branches have been singed. Because what happens, you guys, with trees, and I'll explain this. This is a little bit more complicated than I wanted to get into, but here's what happens with electromagnetic frequencies. They hit the tree, especially a tree with bark on it, and they encounter a dual density bilayer. So once they go through the bark, they hit the heartwood and they ricochet on the inside of the heartwood. And the heartwood heats up and it causes the girth of the tree to shrink. And this all happens very, very rapidly. It causes rapid dehydration, and the branches of the trees are more susceptible to breakage. They can catch on fire quickly, which is why you see the fires on the inside of the trees, because essentially microwave energy will not go directly through a tree. That's why you cannot take an x-ray of a tree, you guys. Because electromagnetic frequencies, once they hit the bark of the tree, they ricochet on the inside of the heartwood, which is why so many trees in front of these cell phone towers lose their bark, because the girth of the heartwood underneath the bark shrinks, so the bark peels off. Okay, I know this is a lot more than you guys probably wanted to know, but the bottom line is I want you to notice that around where these trees have broken, they are charred. Not because there was a fire, but because the heat of the electromagnetic frequencies that are ricocheting on the inside of these trees, it's like it goes into a tunnel and it can't escape. That's why you can't X-ray. You can't X-ray a tree. That's why radar doesn't work in trees, because once those electromagnetic frequencies hit that bark, that dual density bilayer traps that electromagnetic energy inside that tree, and it can literally catch on fire from the inside. That is a telltale sign. That's it, you guys. So that's why these branches just fall right down. That's why those bushes that I showed you, those cedar trees, which are so malleable, do such a good job of giving us the signature that there's been an electromagnetic frequency anomaly here. So yeah, see this is, I don't know, I can't even really see these. I think this is an oak tree. But look at the branches just fell straight down. The tree just fell straight down. You know, there's some really weird stuff happening here. I don't know if you guys have seen the examples where you have railroad fire ties. You know, there are railroad ties that are used in gardening and stuff. The fire will be right in between the ends of them. There's something really messed up happening here. I don't know what accounts for this tree breaking here. I can't tell you that, but I can tell you what accounts for the branches breaking, and why when these are breaking, they're falling straight down. They're falling straight down from the tree instead of being blown across. If this was a tornado, you guys, these branches wouldn't be underneath this tree. If this was a tornado, these trees would be strewn all over the place. Now, there are areas in this particular video where they show, you know, but these are not tornado. This is not tornado damage. These are just broken branches. This is not something we're used to seeing unless there's a tornado. But you guys, there's something messed up happening here. Something super messed up. I mean, because look at the kind of damage that is done with the garbage can just standing right there. The garbage can. Now, if it tore up that tree, if there was wind strong enough to tear up that tree, don't you think it would have hit this garbage can? Don't you think it would have taken out this garbage can? Where is it? Let me just back this up a little bit and show you. There's the garbage can right there. See? So if it took out this huge oak tree, why wouldn't it have knocked the garbage can? Not just this garbage can, but that garbage can, or any of the garbage cans in this neighborhood. So there's something super messed up here happening, you guys. And all we're actually observing, like Like Judy Wood used to say, just look at what you're observing and identify what you're observing. You are observing branches that have fallen down underneath the trees. You are not observing branches that are thrown, half a block away. These are actually just falling right on the houses underneath them. So this is pretty messed up. Now, another thing I want to point out here, the signatures of electromagnetic frequency anomalies is this stuff right here. See these, this is another one of his videos. Right here. See this white rope around this anchor part here on this dock? This is like the only one that's not singed. This is like the only one that isn't fried. The rest of them, with or without a boat, the dock around them is all fried. Another thing to point out here is that these metal winches, these are singed. It's like something caught on fire, but there's no reason for these to have caught on fire. All you have here is like, I don't know, metal and plastic and some metal. So that's screwed up. And then you have these aluminum boats. They all seem to have really taken a beating. And the one boat that isn't aluminum that they do show right up here, look where this boat is burned. This boat, if you want to call it burned, I don't know what the heck happened to this boat, but it's the part that did suffer the destruction first was definitely where the metal motor was in the back. So that's a red flag to me, because metal, you guys, is conductive, which is why you can't put like aluminum foil in your microwave. Okay, it'll explode things. So when electromagnetic frequencies hit metal, they intensify, which is why you're going to end up with these char marks around the metal poles that are holding up these docks. This is what's so freaky, you guys. All the char marks are around metal. And as he walks down this dock, you notice that the docks have sunk because they caught on fire at the part where the metal poles hold them up. This is really messed up. But look at that. The docks have caught on fire at the ends where the metal poles are, just like this boat caught on fire where the metal motor is. See, look at this, and the dock caught on fire here, or charred at least, with the metal base. So there's something, this is, by the way, this is the same area where those side rails on the highway there caught on fire. So this is really sick. And then the last thing I want to show you guys, this one's really sad. This, I'm just going to show you one little clip here. I want you guys to go watch these videos. See this damage right here of this house, and this damage of this house, and this damage of this house. This is new. This is new damage. Okay, this is from this year. But this damage, it's all cleared up. This is from last year. That's messed up, you guys. That's really messed up. So what they didn't finish off last year, they've come through this year to finish up. And I think that's worth noting, because this is really serious stuff. So anyway, go ahead and you guys please do subscribe to Mental Boost channel, and I will keep bringing you my observations as I come across them.